Okay, good morning everyone. We are starting hyperbola, which is in 10.3. Okay, and I will return your test in a little bit. Okay, so just bear with me a few minutes and we will start hyperbola. Now, let me share the desktop. It will be very similar to ellipse. Of course, there are differences, but you will find familiar things with hyperbola. So, one note. Okay, so map to 60 and all right. So 10.3 is hyperbola. Hyperbola. Okay. Now let's talk about the geometric definition. Yeah. So for ellipse, it's fixed distance. The sum is fixed distance from 2 points, but the hyperbola is the difference. Yeah. So let's talk about geometric definition of a hyperbola. Okay. So hyperbola is the set of all points in the plane the difference of whose distance from two fixed points. So this is the difference. Okay, from two fixed points F1 and F2 is a constant. Right? So that's the definition of hyperbola. So if I draw a hyperbola, it will probably look something like this. Oh, hold on. What would happen? Yes. So it will probably look something like this. Okay. What happened? Hold on. So hyperbola look like this, here and here, and your foci are located here. This is F1 and this is F2. So the distance of which from these points are equal. So from here to here and from here to here are equal. The difference. Yeah. Okay, what happened? So the difference are equal. So this minus this is equal to this minus this. Yeah. That's the definition, geometric definition of hyperbola. Okay. Now there are two kinds of hyperbolas. So vertical and horizontal. So what are they? The first one is vertical hyperbola. And then the center is 0, 0. All right. So it's going to look like this. Okay. So the branches are vertical. So the equation would be, now this is where I differ with the book. Yeah. I always use y, b under the y. So this is y squared over b squared minus x squared over a squared is equal to 1. Do you guys want to follow the book? Because it's confusing. I always use b under the y and a under the x. Yeah, so b is always under the y. So this is different from the book, I think. But it's a lot easier because you don't have to memorize the formula. So b is under the y. So let me write down this is different from the book. Okay. Now this hyperbola has asymptote. And then we will graph the hyperbola later. And these are called the asymptotes. The equation of the asymptotes of the hyperbola is y is equal to plus or minus b over ax. So remember, this is rise over run. So rise over run. Yeah, rise over run. Always rise over run. So which one is rise? Rise is whatever is below the y. What is run? Run is always whatever is below the x. Yes. All right. Now this axis is called transverse axis. So I am going to write down that the vertical transverse axis is vertical in this case. So vertical transverse axis. And the focus, what is the equation, the coordinates of the focus, the two foci, 0, plus or minus c, where c is equal to a squared plus b squared. All right. So there are some of the things you have to memorize. So c squared, not c, but c squared is a squared plus b squared. Okay. So can you tell the difference between the equation of hyperbola and ellipse? What's the difference? Yes. What about the coefficient of x squared and y squared? Yes. One is positive, the other one is negative. Right? How do you know this is a vertical hyperbola? Well, if the the right-hand side, assuming the right-hand side is equal to 1, then whatever has positive coefficient, so for example y, then you have a vertical hyperbola. And if you have x squared has positive coefficient, that's a horizontal hyperbola. Yeah. And where are the foci located? It's always on the transverse axis. All right. So if it is vertical, of course, it's on the vertical transverse axis. Now, I'm going to graph the horizontal hyperbola. And then you will see the difference on the equation. Are you guys ready? All right. Good. So, second one, let's see. Were you done? Yeah, continue. Okay. Good. So the second one is B2, horizontal hyperbola. And this one is with center 0, 0. So later on we will talk about translated hyperbola. All right. So horizontal hyperbola look like this. And of course, you also have the asymptotes. Okay. and the hyperbola doesn't cross the asymptote, it's just going to get closer and closer but not touch. All right? All right. Okay, now let me ask, where are the two foci located? On the x, yes. So this is F1 and F2. It doesn't matter which one is F1 and F2. All right. So the equation is, let me see. What do you think the equation will be? X squared over a squared minus y squared over b squared is equal to 1. All right, so here, given that right-hand side is equal to 1, coefficient of x squared is positive. Right? If the right-hand side is equal to 1, coefficient of x squared is positive. All right. Okay, so what happened to this hyperbola? Transverse axis is horizontal. And what about the foci? Foci are c plus or minus c, comma 0, where c squared is equal to a squared plus b squared. What was the formula for the c squared for ellipse? No. It's a squared minus b squared or b squared minus a squared. So you choose one, right, for ellipse. But for hyperbola, it is c squared is equal to a squared plus b squared. So again, this is negative, this is positive, and the asymptotes. What do you think the asymptotes will be? Same thing, y is equal to plus or minus b over a x. Yeah, so the asymptotes do not change. Yes, no? Okay. So remember, the right-hand side is always 1 for hyperbola and ellipse. So it's in standard form. The right-hand side is 1. All right. Okay, good. So, should we do example first, or you want to do the translated one? Example? Okay. So, example. Find the vertices, well, coordinates of the vertices. Here what they call vertices is only these two. Okay, so maybe I should write down, even though when you graph it, there are 4 points. So let me write here. Vertices. So I'm adding here. Sorry. Vertices is plus or minus a comma 0. Do you have to memorize it? Not really. So I just added this part. And I should add the vertices on the other side also. I have to go back to B1 and then write down the vertices. Okay, so those vertices, so this is A, this is negative A. Yeah. A, comma 0 and negative A, comma 0. So what about the previous one? What do you think the vertices would be? 0, comma, plus or minus B. Yes. So that's what I was supposed to do. I have to go back and label that. When you're done. But you're not done? All right. So find the coordinates of the vertices, foci, find the asymptotes, and then sketch. Okay. So y squared over 9 minus x squared over 16 is equal to 1. So I'm going to go back to the previous page, okay, and then write down the vertices when you're done. I'm just going to write down the vertices on the previous one. All right. Oh, by the way, your exam last time was very good. It was a lot of people got 100. I think 4 people. Yeah. Okay, so I'm going to write the vertices here. What was the vertices? So this is foci, asymptotes, and then vertices. What is the vertices? 0, comma, plus or minus b. So this is b here. B and then no, negative b and then b. So the distance is b. Yeah. Okay. So this is what I just added. This is for the previous hyperbola. Yes. That's what I just added. So you sort of know also. Are we ready to go back? Okay. So I just added this on the previous page. Yeah. B1. So this is B2. All right. Good. Now, let's sketch it first. Find the coordinates of the vertices, foci, the asymptotes, then sketch. Once I know the equation, what can I tell from the equation? What type of hyperbola? Vertical hyperbola? Why? That's right, but tell me why. Yes, the coefficient of y squared is positive. All right, so you know this is not an ellipse, right? How would it be if I were to change this equation to an ellipse? What is the difference? So if I just put plus here, then I will have an ellipse. So that is the difference. That is the only difference. That's why we have to pay attention here. Yeah. Vertical hyperbola. Do I know the center? 0, 0. That's right. Okay. And then I could start with my sketch. So for all these conics, we should start with sketch. So this is how I'm going to sketch it. All right. So I will start with 0, 0. And then I will sketch a rectangle. All right. So you start at 0, 0. And then how many units do you go up and down? This is almost the same as ellipse. So if this were ellipse, how many units do you go up and down? 3. So 1, 2, 3. Yes. So 1, 2, 3. So it's just when you start drawing it, it's going to look like an ellipse. Now, how many units do we go left and right? 4. So 1, 2, 3, 4, 4, and then the other one is 1, 2, 3, 4, negative 4. Now, instead of drawing an ellipse, if we were to draw an ellipse, usually we draw an ellipse here, don't we? So we will draw a rectangle. So this is not part of the hyperbola. However, it is useful to draw the asymptotes. So this rectangle is useful for drawing the asymptote. So it's not an ellipse. I will draw the rectangle, and then these will be my my midpoints of each side. So I was using the point. And how do you think I will draw the asymptotes? Any idea? The diagonal. So we will take this diagonal. This is my first asymptote. And another diagonal. This is the second asymptote. All right. Something like this. So those two lines connecting the two diagonals are the asymptotes of the hyperbola. So where is the hyperbola? I haven't drawn it. Have I? Okay. So is it a vertical or a horizontal? Vertical. So am I using this point? No, I'm using these 2 points, right? So then I will draw something like this. It's just going closer and closer to the asymptote but not touch. So your hyperbola is going closer and closer to the asymptote but not touch. Yeah? All right. That's it. That's your hyperbola. Now, can we list all the things that they were asking? So, do we know the coordinates of the vertices? Yes, what is it? 0, 3, and 0, -3. Do I have to memorize the formula? Oh, is it 0, comma, plus or minus b, or a, comma, 0? No, we don't. Where do we get the vertices? From the sketch, right? Okay. Now, do we know the coordinates of, the equation of the asymptotes? Yes. So asymptotes is y is equal to plus or minus b over a x. So this is slope. Slope is rise over run. So look at the equation here. Which one is your rise? What is your b? B squared is 9, so b is 3. What about run? 4. Yes, so y is plus or minus 3 over 4x. So remember, this is the number below the y. Rise is vertical, so we're looking for the number below the y square and take the square root. So we're done with the asymptotes. Now, what about the foci? How do I find the foci? Well, can I get it from my graph? Not really. We have to calculate it. So what letter do we use for foci? C squared is equal to a squared plus b squared, right? So c squared is 9 plus 16. No, actually, a is 16. 16 plus 9, so c squared is equal to 25. What is c? 5. So now I could graph my foci because I don't want to memorize. Oh, what is it? 0, comma, plus or minus c, or c, comma, plus or minus c, comma, 0. So c equals 5. What does it mean? From the center, it's 5 units. Up, down, or left, right? Up, down. Yes. So this one is your foci, 5. So this is -5. This is your foci. So what are the coordinates of my 2 foci?
0, 5, 0.
Yes, 0, 5, 0, -5. Do I need to memorize the formula? Anything? No, everything comes from the sketch. Yes, and the sketch is even more important for translated. For parabolas with center h, k instead of 0, 0, because otherwise you have to memorize, oh, is it h, k plus a, or is it h plus a, k, things like that. So we don't want to memorize the formula. Does that make sense? Okay. Doable? Can you see the similarities and the differences between hyperbolas and ellipses? Can you list some of the differences between hyperbolas and ellipses? What are the differences? Are the equations different? Okay, what's the difference? The coefficient of y squared and x squared are of different signs. Which one have different signs, hyperbolas or ellipses? Hyperbolas, yes. And the formula for c squared? Addition. Yeah, whereas in ellipses it was subtraction. Can we move on? Translate it? Okay. So let's do that. All right. So, is it a D? Let me see. Is it D? C? C, yes. Thank you. C. Translated hyperbola. When we say translated, what does it mean? Shifted. So the center would be H comma K. Yes. So whenever we say translated means shifted. So the center is H comma K. All right. Well, so there are two. So the first one is horizontal hyperbola. Well, why don't we start with vertical? Because that's how we started before. So vertical hyperbola. And then C2 is horizontal hyperbola. All right. I don't think I need to draw it, because we will sketch it later. All right. So vertical hyperbolas. What do you think the equation will be? Or maybe you want me to draw it? I could. So the center is just not 0, 0. So, for example, this is the center, H comma K. And then your hyperbola looks like this. All right. So maybe I should use a different color. So, like this. So what do you think the equation will be?
Y minus K, or Y minus K squared.
Yes, y minus k squared
Over B squared.
Over b squared minus
H, X minus H squared over A squared.
Okay. Yeah, okay. Good. All right. Are we going to memorize the vertices? Oh, the vertices is H, comma, K plus B, and K minus B. No, right? We're just going to sketch them. Now, the asymptotes. How about the foci? Foci is still the same. Well, the asymptote is translated also. So before it's equal to y equals to plus or minus b over ax, remember? So what do you think about these? Well, it's translated. Everything is translated. So what's going to happen here? Y minus k, x minus h. Yes. So same thing. So the translation follows the equation. So you're translating everything h units horizontally and k units vertically, everything. All right. Now, that's vertical hyperbola. Now let's talk about horizontal hyperbolas with center h comma k. Yes, Alex.
Transfer axis is going to be the same?
The transfer axis is this one. So the transfer axis would be shifted too, right? It's going to be vertical, parallel to the y-axis. Yeah. So we just have to graph sketch everything. Yeah. So X, Y. Good. So suppose this is H comma K. So if you want horizontal, it might look like, so it might look like this. And this is H comma K. All right. Okay. What do you think the equation will be? How would it be different from my vertical one? So X minus H squared over A squared, and then plus or minus? Minus Y minus K squared over B squared is equal to, if I change this sign to plus, then we will have an ellipse. Yes. Now, what about the asymptotes? Exactly the same thing. Okay. Y is equal to plus or minus B over AX. But what happens to Y and X? It's translated. So it's not Y, but what? What about the Y? Minus K. It's not X, but X minus H. Good. So you guys get the idea, right? Everything is translated. All right. Oh, the eccentricity. So I forgot. The eccentricity. Do you remember eccentricity last time? What does eccentricity do? Roundness. Yes. So E is C over, in this case, it's B. You know why? Because we're comparing the foci. So the foci will be located here. And then B is the Y. So in here, the eccentricity is E is equal to C over A. Now, do you have to memorize this? Let me think about it. Let me give you like a pointer so that you don't have to memorize. Now, look at this. The first one, C1, vertical hyperbolas. Where are the foci located? Where? Here, right? Foci and foci. So it's a vertical foci. They're located on the vertical transverse axis. That's why you have to compare it with, if you want to know the roundness, then we will have to compare it with the vertical component. Does that make sense? That's why I choose B. Because I need to compare the distance with the vertical component. Now, why is this C over A? First of all, let's see, where are the foci located here on my second one? Probably right here. Okay. So which one do I compare C to? To A, to horizontal component. Yeah. So that's the only thing you have to remember, basically. Right. Now, can we go back to the previous problem and tell me the eccentricity? I forgot to ask. So like for this problem, the one we just did, what is the eccentricity? So this is, I forgot to tell you. What is this? What is the eccentricity? Is it C over A or C over B? C over B. Why? It's vertical. So C is 5. B is, what is B? B is 3, right? You see this is 3? Yeah. So this is your eccentricity. Yeah, I forgot this. So this is eccentricity. So if you can add those.
So vertical C over B and horizontal C over A.
Yeah. And you don't have to memorize that. Let's just see where the foci are located. right? If foci are on the vertical axis, then you compare it with this, with the vertices. If your foci are located in the horizontal axis, then just compare it with this, with the vertices. Does that make sense? Yeah? Okay. Now let's do examples for the translated one. Yeah. Yeah.
For the foci for the translated one, is it still going to be well, c squared equals a squared plus b squared?
Yes. But then it has to be translated.
So it's going to be
H, comma, k plus or minus c. Or h plus or minus c, comma, k. And we don't want to memorize that. Yeah. So we will just sketch it. Yeah. Because otherwise it's difficult to, oh, is it going to be h, comma, k plus or minus c? Or would it be h plus or minus c, comma, k? So we don't want to memorize that. We will just graph it. Yeah. All right. So let's see. Find an equation. Okay, this one. Number 2. Oh, yeah. Why are these? All right. So this one. Okay. This one looks scary, but once we do it, it's not easy. So, for example, graphing a shifted hyperbola. So this is actually an introduction to the next section. So for 9x squared minus 72x minus 16y squared minus 32y is equal to 16. Okay. So what we need to do is complete the squares. To show that the equation represents a hyperbola. B, find the center for the foci asymptotes. So this is like a full-blown problem. And then C, sketch. Actually, we don't do that. We sketch first, right? All right. Okay, so let's go to the next one. Let's see. What should we do first? Any idea? Complete the square. So we're going to combine the x with the x, right? So 9x squared minus 72x minus 16y squared minus 32y is equal to 16. So that's the first step. So x squared and x, y squared and y. Now, can we factor out greatest common factor from 9x squared and 72? So it's not the greatest common factor, the coefficient. So 9x squared minus 8x. Because I need to complete the squares, right? How about this from the coefficient? What am I factoring? Negative 16. And then when I factor out negative 16, what am I left with? Y squared plus 2y equals to 16. All right. Now, do we remember how to complete the squares? What am I adding? 8 divided by 2 squared. So 8 divided by 2 is 4, so this is 16. Now, this is not a real 16. This is what? 9 times 16, which is 144? Yes, both sides. So how do I get 144? Why am I adding 144? Because what you're adding on the left is not 16. It is 9 times 16. Okay. Now, what am I adding here? Plus 1. Is this the real one or a fake one? Fake one. So what is this actually? Negative 16. So what am I supposed to do here? Minus 16 also. Yeah, so this is fake 1, this is fake 16. Supposed to be 9 times 16. So then we have 9 times x minus 4 squared minus 16 times y plus 1 squared is equal to? Okay. Are we done? Well, the right-hand side must equal to 1. So we divide it all by 144. Yay. It's actually not that bad, right? You just have to remember if you're the 16 and the 1 that we're adding, those are fake. So the equation in standard form is x minus 4 squared over 16 minus y plus 1 squared over 9 is equal to 1. Yay, this is the standard form. Doable? Do you know this is an ellipse or a hyperbola? Okay, that's right. Why? Yes, this should be plus if it's an ellipse. All right, now can I start sketching? Can you tell me what the center is? 4, comma, negative 1. That's right. So this is where I start sketching. Right? 4, comma, negative 1. So let me see. Oh, okay. All right. So sketch 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2, 3, 4. So 4, comma, negative 1 is right here. Okay, good. That's where I start. And then I want to draw my rectangles, don't I? So that's where I start. That's where my starting point is. 4, comma, negative 1. Let me wait for you. Let me go give you back in. So this test was really good. 1100. Why? Did you guys think it easier than usual? Okay. So alphabetical order by last name. So Sophia, Jocelyn, Elizabeth, Melissa, Jessie. Oh, I'm not good. Very nice. I think you made it, but there's some calculations that are not. But you got it. So Alexander, Roger, Kevin, Jose Garcia, Matthew, Sandra. So Sandra also get an answer. Yadli, Valentin, Sidney, Josh, Misha, Alfredo. Very good. Fernando, Nicholas Ortiz, Diana, Andrew, Reyes, Jennifer Reyes. Diana, Fernando Cabello. Jose Rios, Sonia, Shion, Jose Jose, Draven, Shion, 100. Okay, 93. Oh, really nice. Jack, Chow, Alexander, Ben. Well, 100 also. Good. Very good. So anyway, it's very good. You guys look at it really quick? Well, you doesn't have to look at it. Okay. Let me see if I have things to give back to you. Did I grade them okay? Did I add them all up correctly? Well, I mean, how many hundreds do I have? Sophia, Hugh, and who else? Who else got 100? I think one Sandra, Chow, four people got 100. Yeah. So it's very good test. Oh, Renee, I have your previous test. This is test chapter 4. It has been sitting there for a while, but I don't have the new one.
It's fine.
So I just made a meeting. Sorry. Did we have this test on Wednesday last week? Yeah? Okay. That's why I didn't get it. Yes? No questions on the test? Now, should we work on these now? All right. So I start with my center. How many units do I go left and right? Remember, I have to draw my rectangle, right? How many units do I go left and right? 4. Yes. So left 4 and right 4. So 1, 2, 3, 4. All right. So this is for 8 comma -1. All right. How many units do I go up and down? 3. How do you know it's 3? Well, a square root of 9 is 3. So 1, 2, 3. So this is 4 comma 2, and go down is 4 comma -4. Yes. All right. Then I will draw ellipse or what? Rectangle. Because I need to draw the asymptotes, right? Okay. Now, how do I draw the asymptotes? Well, you connect the 2 corners, opposite corners. So the diagonal, so the 2 opposite corners of your rectangle. So this and this, opposite corners. Of course, it has to pass through the center, right? The asymptotes have to pass through the center. All right, so you're done. So we're connecting the 2 opposite corners, the 2 opposite vertices, non-adjacent vertices. Okay, now what? Am I drawing a vertical one or a horizontal one? Horizontal, yes. How do you know it's horizontal? Coefficient of x squared is positive, so yes. So I'm using this vertex right here. And then it's going to get closer and closer to the asymptote, but not touch. Yay? Nay? Okay. Horizontal, yes? So, that's it. We're done with our sketch. So, now, can you tell me what is the vertices? Horizontal hyperbola. What about the transverse axis? So, is it vertical transverse axis or horizontal transverse axis? Horizontal transverse axis. So it's called transverse axis. So there is no major axis or minor axis, which is called transverse axis. At ellipse, you have major, the longer one, and minor. So this one, they have one axis. What about the vertices? Yes. So we don't have to memorize. Oh, is it h minus a comma k, h plus a comma k, or h comma k plus b, k minus b? Right? So we just see it from here. What about the two foci? What letter do we use for foci? C square is a square plus b square. So c square is 16 plus 9. So what is c? 5. Yeah. So square root of 25, which is 5. So now, where are your foci? Okay. So we start where? At the center, and then how many units do we go to left and right? 5. Yes. So this is your foci. So 5. And then this is 4, right? So one more. Now, do I know the coordinates of the foci? Yes. What is it? -1, comma -1, and yes. Do I have to remember? Oh, this is h minus c, comma k, h plus c, comma k? No, we don't. Right? We will just graph it here. Does that make sense? So that's how to minimize memorizing. I don't want you to memorize. Yeah, because it's confusing. Eccentricity. Well, I always forget to ask. What is the eccentricity? Is it C over A or C over B? Yeah, so C is foci, so 5 divided by 4. Yeah. That's it. Done. I'm waiting for questions. Oh, the asymptotes. You're right. Asymptotes. What's the asymptote? So let's just write down the formula. I always forget this. C over AX. But those are not true, right? They're shifted. So I'm going to look at this. So Y will shifted what? +1. So the asymptotes follow. +1. And then the X is what? X minus 4. So I'm just going to use it. X minus 4. Do I know B over A? What is B over A? So B is 3 over 4. X minus 4. Do I need to do anything here? No, we're done. We leave it in this form. So you're not solving for Y. You're not doing anything. Leave it in that form. Got it? Okay, good. Now, let's do 10.4. I'm done with 10.3. Yeah. Let's see. I have 10 minutes. I think we could do it. Yeah. 10.4. 10.4 is short. You're just going to say, oh, this is a parabola, this is a conic, this is a hyperbola, this is an ellipse. So let me save this, and we're done with 10.3. Would you be able to start looking at your sample test? Should we have a chapter 11 included in our test, or you just want chapter 10? So chapter 10 is practically conic. Just 10? Yes. I think the first number up to 40 something. Okay. When did we start for last time? Like 41, right? 44. So it's going to be number 1 to 43. Okay. Yeah. So do you guys want to do that? Just have chapter 10 test? Yeah? Okay. So, okay. So when would you like to have it? Wednesday? Next week, too long, because we will be done, I think, tomorrow. Thursday? Wednesday is the class. How about the following Monday? I think better that following Monday is better than Thursday. Do you think so? So the following Monday? Okay. So next week, basically. Okay. Okay. Well, you're the boss, right? I'm only helping you. If you say, oh yeah, we're going to do well if you give a test on Monday, oh, I would be happy to do it. If, I would be really happy, yes. So I was happy with this test, with the previous test, yes. So Monday, we decided on the following Monday, right? Okay. Okay, so let's do that, yes. Now, let me save this and let's start 10.4. So 10.4 is actually really short. It's math to 60. Let's save this. Yes, it's good. Okay, let me close this first, and then I have to load content. Usually I load a few, but then we never finish, right? Today I only loaded one, and we finished. We finished early. So, oh, it's the hyperbola again? I'm sorry, this is supposed to be 10.4. So, yes, this is 10.4, so let's start, okay? Okay, so 10.4. All right. Shifted, general equation of shifted conics. So, general equation for shifted conics. And you'll recognize this right away, okay? So this is the equation, ax squared plus, I don't know why they don't use b, so this is the books. I want it to be similar. cy squared plus dx plus ey plus f is equal to 0. I thought they would have a B, but it doesn't. So I don't know. This is from the book. Yeah, I just want them to be exactly the same. Now, do you remember when we say it's a parabola? Do you remember when an equation is a parabola? How can you tell, oh, this is a parabola or an ellipse? The x squared parabola only has what? 1x squared. So this is how we say it. So a parabola is either A or C, but not both, is 0. Right? So that's how we say it. It's either A, if you have either x squared, maybe let's write down in terms. So this just means, what does this mean? Means either x squared or y squared exists, but not both. So that's what it means. All right. Now, what about when will it be an ellipse? An ellipse is what? So how can you tell, oh, this is an ellipse, not a hyperbola? Remember that? Coefficient of x squared and y squared have equal signs, right? So if A and C have the same sign, so how does it translate to human language? Okay, so means if both coefficients of x squared and y squared are the same sign. That's what it means. Okay. When is it a circle? Remember, a circle is a special type of ellipse. So if A is equal to C, then what will we have? Circle. Yeah, a circle is a special type of ellipse. You go 3 up, 3 down, 3 left, 3 right, that's a circle. Yeah, if A is exactly the same value of C, then it is a circle. Yeah. And when do we have hyperbola? What happens to A and C? If A and C have what type of sign? Opposite sign. Okay, and how do we say? The coefficient of x squared, coefficient of x squared and y squared have opposite. All right. Okay, what is degenerate conics? So, and then there is more degenerate conics. A degenerate conics has a graph, a conic, has a graph which is not a conic. So sometimes you can't graph it. So I'm going to give you an example. So it's not a conic. So not a circle, ellipse, parabola, or hyperbola. So sometimes you have an equation that you can't graph it. I'm going to give you one example now. All right. Okay. So sometimes it's a point or a pair of lines or no graph at all. Let me write down a little bit. So sometimes the graph of a degenerate conic is a point, a pair of lines, or no graph at all. Or no graph at all. All right. So that's what it is sometimes. Okay, I have 1 minute. I'm going to give you one example, but we will continue tomorrow. Yeah. So you have an idea. But basically, this section is very short. Yeah. All right. Ready? So one example. Yeah. So for example, determine the type of conics, if any. The type of conic if not degenerate. Okay, so number 1. X plus 7 squared plus y minus 5 squared plus 4 equals 0. So what would you do here? What were you trying to do? Vector? Yes. So x plus 7 squared plus y minus 5 squared is equal to -4. And then what is your conclusion? Can we graph something like this? Look at this. This is a square, right? This is also a square. Can it be a negative value? No. So this is an equation which has no graph. Right? You can graph it. This is a positive. Anything square is 0 or greater. Anything square is 0 or greater. How can it be negative? Right? Okay, so this one has no graph. This is an example of an equation of degenerate conics. Yay, nay? Okay, so basically, this section will be about saying, oh, this is a hyperbola, this is a parabola, this is nothing, we can graph these, things like that. Make sense? So I think you can get started on the homework. Pen 3 and Pen 4, right? Now, I'd like you to look at the sample test. You know why? Because there are some word problems. And every time I don't have time to do the word problems, but I will when I do review. Okay? So the sample test has word problems. I'd like you to try them. All right? Okay. Good. So I will see you tomorrow. Thanks for coming today. Hello, Andrew.
It comes with the book and everything.
Oh, that's your homework? Okay.
It's called Help on the Shelf.
Let me see. Did you complete it?
No, it isn't. It's well done.
And then I'll give it back to you and change the grade and everything.
I didn't put in the last two sections, my name and my name.
Oh, you don't? You have them or not?
I don't have them with me.
But do you have them at home? Did you do them? Oh, okay. All right, then I'll look at it. I'll give it to you tomorrow. Okay? Okay, so we'll see.